The National Electrical Code, specifically Section 210.52d, addresses receptacle placement in bathrooms. This code section mandates that at least one receptacle outlet must be installed within 3 feet of the outside edge of each basin. Considering the guest bathroom, placing a ground fault circuit interrupter (GFCI) receptacle 6 feet from the sink edge will not meet inspection requirements. The code is very specific about the maximum distance allowed between the receptacle and the basin. For the master bathroom, there are a couple of considerations. Firstly, installing a GFCI outlet over the mirror is not permitted, considering Section 210.52d states a receptacle should be located within 3 feet of the sink. Secondly, feeding the light fixture or receptacle in the master bathroom from a GFCI receptacle located in the guest bathroom is also not an acceptable solution. A GFCI receptacle in one bathroom cannot protect a receptacle located in a separate room. A possible solution would be to cut a hole in the wall to the left of the vanity in the master bathroom, even if it's not within the 3-foot distance from the sink. Installing a GFCI outlet in this newly created space, and then feeding it from the bathroom circuit would provide the required GFCI protection for the vanity receptacle. The importance of ground fault circuit interrupter GFCI protection in bathrooms is primarily safety. Water and electricity create a dangerous combination, and GFCI devices are designed to quickly interrupt the electrical circuit when a ground fault is detected. A ground fault occurs when electricity flows through an unintended path, such as through a person who is in contact with a live wire and a grounded surface. GFCI devices monitor the current flowing to and from an electrical device. If there is an imbalance, even a very small one, it indicates that some current is leaking to ground. The GFCI then trips, cutting off the power to the circuit within milliseconds. This rapid interruption can prevent serious injury or even death from electrical shock. The 3-foot rule is intended to ensure that a GFCI protected receptacle is readily accessible for plugging in appliances such as hairdryers, curling irons, and electric shavers, which are commonly used near water sources in bathrooms. By requiring a receptacle within close proximity to the sink, the code aims to minimize the use of extension cords, which can increase the risk of electrical shock if they come into contact with water. When working with electrical wiring, always prioritize safety. If you are not comfortable working with electricity, it is best to hire a qualified electrician. Electricity can be dangerous, and improper wiring can lead to electrical shock, fire, or other hazards. Before starting any electrical work, turn off the power to the circuit at the circuit breaker panel. Use a voltage tester to confirm that the power is off before touching any wires. Wear appropriate personal protective equipment, such as safety glasses and gloves. Follow all applicable electrical codes and regulations. If you are unsure about any aspect of the work, consult with a qualified electrician. When installing a GFCI receptacle, be sure to follow the manufacturer's instructions carefully. The receptacle should be properly grounded to ensure that it functions correctly. Test the GFCI receptacle after installation to verify that it is working properly. Most GFCI receptacles have a test button that can be used to simulate a ground fault. When the test button is pressed, the receptacle should trip and cut off power to the circuit. If the GFCI receptacle does not trip when the test button is pressed, it may be faulty and should be replaced. There are several types of GFCI receptacles available. Some GFCI receptacles are designed to protect only the receptacle itself, while others are designed to protect the entire circuit. Circuit breaker type GFCI devices are installed in the circuit breaker panel and provide protection for the entire circuit. These are often used for bathroom circuits, as they can protect all of the receptacles and lighting fixtures on the circuit. Outlet-type GFCI devices are installed in place of a standard receptacle and provide protection only for the receptacle. These are often used in bathrooms where only one receptacle needs GFCI protection. When choosing a GFCI receptacle, be sure to select one that is appropriate for the application. Consider the number of receptacles that need to be protected and the location of the receptacle. The National Electrical Code (NEC) is a set of standards for the safe installation of electrical wiring and equipment in the United States. The NEC is updated every 3 years, and it is important to stay up to date on the latest requirements. The NEC is not a law, but it is widely adopted by state and local governments. In many jurisdictions, electrical installations must comply with the NEC in order to be approved. The NEC covers a wide range of topics including wiring methods, overcurrent protection, grounding, and equipment installation. It is a comprehensive resource for electricians and other electrical professionals. In addition to Section 210.52d, there are other NEC sections that are relevant to bathroom wiring. For example, Section 210.8 requires GFCI protection for all receptacles in bathrooms. Section 404.4 requires that switches be located so that they cannot be readily touched by a person using the bathtub or shower. When planning a bathroom electrical installation, it is important to consider all of the applicable NEC requirements. Working with electricity can be dangerous, so it is always best to consult with a qualified electrician if you have any questions or concerns. GFCI receptacles are an important safety device that can help to prevent electrical shock. By following the NEC requirements for receptacle placement and GFCI protection, you can help to ensure the safety of yourself and others. When dealing with older homes, electrical systems often present unique challenges. Wiring may not be up to current standards, and there may be a lack of grounding or GFCI protection. In these situations, it is important to carefully assess the existing electrical system and make any necessary upgrades to ensure safety. In the specific case of the old house with 2 slot receptacles built into light fixtures over mirrors, several issues need to be addressed. Firstly, the 2 slot receptacles are not grounded, which is a safety hazard. Secondly, the location of the receptacles over the mirrors may not be ideal, as it may not be within 3 feet of the sink. Thirdly, there is no GFCI protection for these receptacles. One approach to upgrading the electrical system in this situation would be to replace the 2 slot receptacles with grounded receptacles. This would require running a ground wire to each receptacle, which may be challenging in an older home. Alternatively, a GFCI receptacle could be installed upstream of the existing receptacles, providing GFCI protection for all of the receptacles in the circuit. This would be a less invasive approach, but it would not address the lack of grounding. Another option would be to install a new receptacle outlet within 3 feet of the sink, as required by the NEC. This could involve cutting a hole in the wall and running new wiring to the receptacle. The new receptacle should be GFCI protected. In the guest bathroom, the pocket door presents a challenge, as it limits the available space for installing a receptacle. However, it may be possible to install a receptacle on the wall to the left of the vanity, even if it is not within 3 feet of the sink. In this case, a variance from the local electrical inspector may be required. In the master bathroom, the window on the exterior wall presents a similar challenge. However, it may be possible to install a receptacle on the wall to the right of the mirror, even if it is teed into by the pocket door of the guest bathroom. In this case, it is important to ensure that the wiring is properly installed and that the receptacle is GFCI protected. Ultimately, the best approach to upgrading the electrical system in an older home will depend on the specific circumstances. It is important to carefully assess the existing electrical system and consult with a qualified electrician to determine the most appropriate and safe solution. One thing to note when placing a GFCI is the load side and the line side. The line side is the incoming power, and the load side is the outgoing power to the rest of the circuit. If they are mixed up, it will not work properly. Another thing to note is the ampacity rating. Make sure it is rated properly for the circuit. It is also important to use the correct wire gauge based on the ampacity of the breaker. For example, a 20 amp breaker will need at least 12 American wire gauge AUG wire. When working on electrical in old houses, do not assume anything. For example, do not assume the wires are correctly color-coded. Always check with your meter to verify that they're correct. If you have aluminum wiring, it is also best to have a qualified electrician to help with that. Aluminum wiring requires different methods of termination as well as using antioxidant paste. First and foremost, always turn off the power before working on any electrical device. It is best to use a non-contact voltage tester to make sure the wires are not energized before touching them. In older homes, it may be a good idea to replace the entire electrical panel. If it is an older panel, it may not be up to code, or it may not have enough spaces for all the breakers you need. Make sure to get a permit if needed before doing any electrical work. A licensed inspector can come out and make sure that all work is up to code. Furthermore, Section 210.11c3 of the NEC requires at least one 20-amp circuit to supply bathroom receptacle outlets. This is in addition to any other circuits that may serve the bathroom, such as lighting or exhaust fans. The intent of this requirement is to provide sufficient power for the simultaneous use of multiple appliances, such as hair dryers and curling irons, without overloading the circuit. A 20-amp circuit must serve only the bathroom receptacle outlets and cannot supply any other loads. This helps to ensure that there is adequate power available for the bathroom receptacles and reduces the risk of overloading the circuit. The 20-amp circuit must be wired with 12 American wire gauge AUG wire, which is rated for 20 amps. The receptacle outlets in the 20-amp circuit must be rated for 20 amps as well. When installing the 20-amp circuit, it is important to follow all applicable NEC requirements. This includes properly grounding the circuit, using the correct wiring methods, and installing the receptacles in accordance with the code. If you are unsure about any aspect of the installation, it is best to consult with a qualified electrician. The exception to the 20-amp rule is in dwelling units, where a 20-amp circuit can feed multiple bathrooms. However, the bathrooms must be on the same dwelling unit. When performing any electrical work, you want to follow lockout, tag-out, LOTO procedures to protect yourself and others. Firstly, identify the circuit that you will be working on. Secondly, turn off the circuit breaker that supplies power to the circuit. Thirdly, verify that the power is off using a voltage tester. Fourthly, attach a lock and tag to the circuit breaker to prevent it from being accidentally turned back on. The tag should identify the person who is working on the circuit and the date and time that the circuit was locked out. Fifthly, when the work is completed, remove the lock and tag and restore power to the circuit. Following LOTO procedures helps to ensure that the circuit remains energized while work is being performed, preventing electrical shock or other injuries. The 3-foot rule for receptacle placement in bathrooms is measured horizontally from the edge of the basin. The receptacle outlet must be located within 3 feet of the outside edge of the basin, as measured horizontally. There is no vertical height requirement for the receptacle outlet. However, the receptacle outlet must be readily accessible and cannot be obstructed by any permanent fixtures or appliances. The receptacle outlet should be installed at a convenient height for users to plug in appliances. A typical height for a bathroom receptacle outlet is between 12 inches and 48 inches above the finished floor. The height of the receptacle outlet should be consistent with other receptacle outlets in the bathroom. When installing a receptacle outlet in a bathroom, it is important to consider the accessibility requirements of the Americans with Disabilities Act, ADA. The ADA requires that receptacle outlets be accessible to people with disabilities. This means that the receptacle outlet must be located at a height that is reachable from a wheelchair and that the receptacle outlet must be operable with one hand. Furthermore, Section 406.9c of the NEC prohibits face-up receptacles on countertops or similar surfaces. This is especially true in bathrooms. All receptacles need to be installed in a manner that prevents water from getting inside. Using weatherproof covers are also recommended. When selecting wiring, you will need to choose the correct type. For example, non-metallic sheet cable, such as Romex, is commonly used for residential wiring. The cable consists of 2 or more insulated conductors and a grounding conductor enclosed in a non-metallic sheath. The cable is typically run through walls, ceilings, and floors. Another type of wiring is electrical metallic tubing, also known as EMT. EMT is a rigid metal conduit that is used to protect electrical wiring. The wiring is pulled through the conduit after the conduit is installed. EMT is commonly used in commercial and industrial buildings. When selecting wiring, it is important to consider the ampacity of the circuit, the environment in which the wiring will be installed, and the applicable electrical codes. It is also important to use the correct connectors and fittings for the type of wiring being used. If you are unsure about any aspect of the wiring installation, it is best to consult with a qualified electrician. Another thing that can be done is to install an arc fault circuit interrupter, a GFCI breaker. GFCI breakers are designed to protect against arc faults, which are a common cause of electrical fires. Arc faults occur when electricity jumps between two conductors, creating a spark or arc. This can happen when wiring is damaged, loose, or corroded. GFCI breakers detect arc faults and quickly trip, cutting off the power to the circuit. This can help to prevent electrical fires. GFCI protection is required in many areas of the home, including bedrooms, living rooms, and dining rooms. However, GFCI protection is not typically required in bathrooms. This is because bathrooms are already required to have GFCI protection, which provides protection against electrical shock. However, GFCI protection can still be a good idea in bathrooms, as it can provide additional protection against electrical fires. GFCI breakers are available in both circuit breaker and receptacle types. Circuit breaker type GFCI breakers are installed in the circuit breaker panel and provide protection for the entire circuit. Receptacle type GFCI breakers are installed in place of a standard receptacle and provide protection only for that receptacle. When selecting an GFCI breaker, it is important to choose one that is appropriate for the application. Consider the type of wiring being used, the location of the receptacle, and the applicable electrical codes. If you are unsure about any aspect of the GFCI installation, it is best to consult with a qualified electrician. With all that said, there may be some appliances that do not function with GFCI protection. Some older refrigerators or appliances with motors can cause nuisance tripping of the GFCI device. In these cases, it is best to plug them into a non-GFCI protected outlet. However, it is still important to ensure that the outlet is properly grounded. Also, when choosing lighting, make sure they are rated for the location. For example, wet-rated lights need to be used for showers and outdoors. If a light is not rated properly, it can be a safety hazard. There are many options available, and it is best to consult with a qualified electrician if you are unsure which lights to choose. If the location is a damp environment, make sure the light fixture is rated for a damp location. A damp location is an area that is subject to moisture, such as a bathroom or laundry room. A wet location is an area that is subject to direct contact with water, such as a shower or outdoor area. The rating will be specified by the manufacturer.